Our next section is on Chapter 7, Vitamins, for the final exam review. And first we'll take a look at the two different types of vitamins. We have our water-soluble vitamins, vitamins C and B, and our fat-soluble vitamins, A, D, E, and K, which is what we'll start talking about. It's important that you know the different characteristics associated with the solubility of the vitamins. For example, the water-soluble vitamins dissolve easily in water, not surprisingly. But that means they're easily absorbed because the blood's an aqueous environment, easily transported. They're not stored in significant quantities, and they're rarely toxic from food. Now, on the other hand, if we look at fat-soluble vitamins, they don't dissolve in water, so they need fat in order to be absorbed. They are stored extensively and, in some cases, can reach toxic levels. As I said before, vitamin A, D, E, and K are fat-soluble vitamins, and if we look at vitamin A, we know that vitamin A is important in vision, growth and maintenance, and immune defenses. So that means that a deficiency of vitamin A can result in night blindness, keratization, and decreased immunity. And that's keratinization. Now, beta-carotene is a pigment in plants and is a precursor to vitamin A, but it also acts independently as a phytonutrient or an antioxidant. So it can be converted to vitamin A once it's in the body, but it's not absorbed at a really high rate. So the sources of vitamin A, when we think of vitamin A, we think of retinol. We think of this yellow fat soluble substance. See, vitamin A occurs in animal foods, and probably one of the greatest sources is going to be beef liver. Now, beta-carotene, or any of the provitamin A carotenoids, usually always come from plant sources, but sweet potato, cantaloupe, red pepper, anything that's going to have that orangey pigment or that bright red pigment. So the carotenoids are plant sources, the retinol, vitamin A, is going to be an animal source. Remember, vitamin D is our next fat-soluble vitamin. Vitamin D essentially regulates calcium metabolism. Specifically, it enhances calcium absorption. Vitamin D deficiency can result in softening of the bones in a disease called rickets, which is not all that common. It's called rickets in children and osteomalacia in adults. But what we found in more recent years is that vitamin D deficiency is also associated with a number of common chronic diseases, such as heart disease, cancer, cognitive development, asthma, diabetes, MS, and hypertension. Vitamin D can be toxic, so getting too much vitamin D can be problematic, and that can result in soft tissue calcification, calcified arteries, or calcification in the heart. Vitamin E. The main role of vitamin E is as an antioxidant. And I already showed you this slide, but essentially shows you how vitamin E acts as an antioxidant by quenching the free radicals, basically stopping this progression, because the free radicals are very unstable. They want to bind to protein, they want to bind to cell membranes, to DNA. And an antioxidant essentially blocks this. They quench the free radical, they stop this progression, because once you cause the damage, then it leads to some types of chronic disease, particularly cancer. Vitamin K is our next fat-soluble vitamin, and remember there are two types. K1 is involved in the synthesis of blood clotting proteins, where K2 is involved in the synthesis of bone proteins. Now, you don't need to know, I don't expect you to know this much detail, but I do want you to know that think of K1 as the plant form, and K2 typically is an animal form of vitamin K. So you're going to receive that or obtain that from animal products. Now, vitamin K2 is made in the intestines, but it isn't absorbed very well. So a deficiency of K1 is uncontrolled bleeding. It's not that common, because K1 is recycled really well. K2, a deficiency can result in fractures, there are bone proteins, and then heart disease. Remember I talked about vitamin K and vitamin D working together, where vitamin D is the gatekeeper. This controls how much calcium is going to come into the body. But once calcium gets into the body, it doesn't really know where to go. So you need vitamin K2, that traffic cop, to direct calcium once it's absorbed. On to the water-soluble vitamins. Vitamin C, probably one of our most common, most well-known vitamin, is not just for what people think it's for, which is preventing colds, but has a number of different functions. One of the most important is the maintenance of connective tissues, so in the formation of collagen. It's also a cofactor in the production of carnitine. On its own, it acts as an antioxidant, and in that role, it helps to restore vitamin E to its active form while supporting the immune system and boosting iron absorption. Oh, and I do have to go back. So, decreased amounts of vitamin C are associated, vitamin C deficiency is associated with scurvy. We don't see scurvy that much. Remember, taking vitamin C as a supplement might help decrease some of your symptoms of a cold or reduce the length of time maybe by a half day, but it's not going to prevent your common cold. The other water-soluble vitamins are the B vitamins, and these are important because these all work together. And so I want you to think of them as part of coenzymes, of working together. They're involved in energy metabolism and new cell synthesis. And that encompasses pretty much all the B vitamins. Now, I'm going to select out a couple B vitamins with some very specific functions and deficiencies I want you to know. For example, B1, which is thiamine. This is, again, involved in energy metabolism in cells, so specifically with carbohydrates, amino acids, and fatty acids. Deficiency results in beriberi. So beriberi affects the nerves and starts out by losing sensation in the fingers and then the toes, but can result in muscular weakness or even advancing paralysis. Riboflavin B2, so again, involved in energy metabolism. If there's a deficiency, there's going to be, you see the cracks around the mouths and a rash and even this bright red tongue. Milk is one source of riboflavin, and remember, milk has to come in a cardboard box or UV protected glass because UV light can destroy riboflavin. So good sources of this, aside from milk, are yogurt and some types of grains. And here are some examples of ways that riboflavin is protected. Niacin, we're on to B3. So niacin, again, is a coenzyme involved in energy metabolism. Deficiency results in something called pellagra, otherwise known as the 4 deadly Ds. So diarrhea, dermatitis, dementia, and death. Here you just see the dermatitis, so changes within the skin. B6. B6 has kind of this diverse range of functions involved in over 100 different reactions in the body. Everything from converting amino acids to releasing stored glucose, immune function, and brain development. So I don't care that you know those in particular, but I just want you to know it has a very broad range of functions. Folate. Folate is one of extremely important B vitamin, and because it has a stronger or more important role in new cell synthesis, basically forming DNA and synthesizing or basically putting together amino acids. Now this is important because if we don't have those new cells synthesized, especially our spinal column formed, then we can end up with what's called a neural tube defect. And this forms in the very first few weeks of pregnancy before many people know they're pregnant. So you can't just pop a folate supplement after you're pregnant and then hope that this won't happen. So having adequate amounts of folate if someone's trying to get pregnant is crucial. Spina bifida is the main neural tube defect, and essentially the spinal column does not form well. The spinal cord protrudes out the back. I see this bubble here, but this leads to just really severe problems all throughout life. And it's very unfortunate because it can be, for the most part, prevented. Remember that once fortification started in the mid-90s, that it did decrease the incidence of neural tube defects. The last of our water-soluble vitamins, our B vitamins, is a B12. This maintains nerve sheaths, it protects the nerve fibers, and is also important in hemoglobin synthesis, which means that a deficiency can result in problems with the nerves, shocking, or even in anemia. So pernicious anemia is what this anemia is called. There are different types of anemia, not just an iron deficiency anemia. So B12 deficiency can result in pernicious anemia, can also cause tingling, numbness, loss of sensation in the hands and the feet. I actually see that, not uncommon. This is generally due to malabsorption in the elderly. And vegans are also at risk. A lot of vegans will have nutritional yeast in order to get their B12 or take a supplement. B12 food sources, crab, pork, tuna, cheese, beef. Basically, you're looking at all animal products, right? So with the exception of that nutritional yeast, B12 is the naturally occurring sources of B12 occur in animal food sources. And that's going to be the end of this section on vitamins.